All right, so the topic on this section is relentlessly focus on simplicity. Let me share a few stories first, and then let me talk about how you can apply this. There are a few experiences that have really, really changed me as a person, as an educator, as a teacher, and of course as an entrepreneur and other things. But focusing on the teaching side. So I went to Caltech for my graduate school in engineering, and I had my advisor who was so smart, so smart. Yeah, I just don't know how else to describe him. Very smart and very gentle, very, very nice. He was teaching a class called, what's it called? Statistical mechanics. I mean, this is it's been a while, but it's an advanced course. It's a very advanced course, and he was teaching that course. We had about 20 students in that room. And at Caltech, what was interesting, not only my advisor who was teaching that class, but all the instructors at Caltech, they were using just a plain old blackboard, not even a whiteboard like what I have on the back, just blackboard and chalk. They didn't use PowerPoint, just chalk and them on a blackboard. That's how all the lessons were taught. It was simple. It was very engaging because we would, write things together with the teacher, and it was very effective. But I found it refreshing to move away from PowerPoint based training, which I don't like. It's not engaging. The power of chalk was just so powerful and so simple. So that experience has impacted me. But this one day, my advisor comes in and he's teaching us about this fundamental laws. So he goes over and he teaches this, he write it down, and he explains things along the way. It makes sense. It's like, oh, this is making sense. This is very simple. And after about 30 minutes, he says, okay, that's it. That's everything you need to know about thermodynamics. And when he said that, I'm thinking, what? This is everything you need to know about thermodynamics. Everything can be derived from this. I'm thinking, no way. Because what you taught me was just so simple. And it made sense, but you covered that in 30 minutes. And there are classes and classes and classes, books and books and books covering about thermodynamics. And you're saying everything, all of that can be derived from this? You must be lying. I mean, you're just full of shit, is what I'm thinking. I've never said it out loud, but I'm thinking that. And then I looked at my other classmates and they're like, what? Did we just hear what we heard? It can't be. It just cannot ever possibly be this simple. So there was a big discussion at the end of the class. We were like, what? I mean, this can't be right. I mean, how could it be? What people usually spend months and months, and people have written textbooks and textbooks and volumes of textbooks on this topic, our advisor basically just taught that and said, that's everything you need to know, and everything is really just derived from these. We couldn't believe it. It took me about 3 weeks to be convinced that my advisor was right. And that, in fact, all the volumes of books written about thermodynamics was written by people who didn't understand the simplicity. And that really, really shook me to the core. I thought people who wrote books and books and volumes of books were the smart ones. Yet, here's my advisor, extremely smart. He saw through the simplicity. And after weeks of assignments and assignments and assignments, I found that, yeah, I could solve all of these using what he covered in that 30 minutes. Profound. That was a profound experience for me. At Caltech, I had other experiences like that where the teacher would explain things and I'm like, oh, that's so simple. That's so obvious, isn't it? And then I find that what they taught are advanced concepts that were actually not taught at schools yet. Is being published on the latest scientific journals. but it just made sense. But the teacher really found a way to teach it so simply that students are like, how this is obvious. What is obvious to students is often not obvious to others, right? Especially if you're taught by what I think are master teachers. Master teachers really have the power to see the world in a very simple way and be able to convey that very simply to the students. The students, when they're being taught by the master teacher, often doesn't know the power of that simplicity, or they just don't question it because it just seems like it's obvious. And it may take them years later to find out that the reason it seems so obvious to them wasn't because how smart they were, but because the master teacher found a way to introduce that concept in the most simple way possible. That, I think, is what we need to do as teachers, to find how do we teach something that's so complex, but how do I explain it, almost fake it, so that students at the end walk out thinking, oh, duh, this was easy. That's when you know you succeeded. When you taught things very, very complex, students are very kind. They're not that judgmental mostly. So they will walk out thinking, oh my goodness, my instructor is so smart, but I will never be that smart. And I didn't really understand a thing that was going on. Well, that's when you know that you weren't taught by a master teacher. That's when the teacher still needed to level up, in my opinion. Okay. So again, I'm trying to be just blunt with my opinion. It's my opinion, and I think what I have learned and the techniques could help you level up. But again, I'm not God, so it's a lot of these are my opinions that I found helpful. Okay. Coding Dojo tool, when I founded that and when I work on that, it took several iterations to get Coding Dojo to where it is. When I first started creating curriculum to train people how to be a self-sufficient software developer, I thought I could do it in 3 months. It took me about 2 years of iteration to finally get to the point where I could get someone who got a CS degree or IT degree, and in a matter of few months, get them to a point where they could now contribute in my engineering team. But it was really hard in the beginning. And in fact, now looking back, it's really funny because when I started doing that, no one believed that I could do that. No one believed that it's possible to train someone in a matter of few months to do what people normally took 5 to 10 years to master. But I thought I could probably figure out a way. I thought it would be fun to figure out a way. I thought I could figure out faster. It took me about 3 years, 3 years to get to the point where I could do that in 3 months. And that was just one language, one programming language stack. But I remember some of the developers coming to me and saying, Michael, I just don't believe you. It's just not possible. I watched thousands of hours of videos. And, some of the concepts that you said you're teaching your engineers, I don't even know myself. How could they have possibly learned that in a few months? Now looking back, 10 years later, coding schools exist and it's proven, right? My students at Coding Dojo, a lot of them are now working as senior software engineers in a lot of top tech companies. They worked hard, right? I think Coding Dojo provided that stepping stone for them. So I don't claim that I taught them everything, right? But I think I really contributed in accelerating their learning curve, and helping them reach that milestone faster. Okay, but kind of coming back to the simplicity, it is the process of iteration that helps on teaching, because what I was able to help people learn in 3 months, after 3 years of iteration, after more iteration, I was able to get it down to 2 months. Was able to get it down to a month and a half. I even got it down to about 5 weeks. And at that point, I said, wow, I could have never imagined when I created these courses, which I later spun off as Coding Dojo, that I could teach these amount of materials in 5 weeks, or that people could actually absorb that much information and get to that level in 5 weeks. I was blown away. Yes, I was having students work 70, 90 hours a week, but still remarkable because it took me years to get to that point. And I see my students now able to do it in 5 weeks. This is now after about 5 to 6 years of iteration. And at that point, then, as you may know, if you're involved with Coding Dojo, then I introduced another stack, and now Coding Dojo is the only school I know of that teach 3 stacks in 3 months. I could never do that. I could have never thought I could do that when I started working on curriculum. But it was a byproduct of iteration, really trying to focus on what are the must-to-knows? How can I level up people faster, save them time. And that resulted in the curriculum where I think people are learning incredibly fast. They're picking up a lot of tool sets. Hopefully they're still focused a lot on the fundamentals and they walk out with confidence. I can build anything using any technology, even if I haven't learned them yet, right? That's the most powerful thing. But now looking back at Coding Dojo, what led to some of that breakthrough on helping people learn things faster? A lot of it had to do with this topic, relentlessly focus on simplicity. So for example, object-oriented programming. Oh my goodness, this is a topic that computer science students struggle for months. Sometimes even their first year or second year, they're struggling and they don't fully understand object-oriented programming. They know how it works, but they haven't reached that mastery. I know when I first learned OOP when I was a kid, that I struggled for months. So yes, when I initially created the curriculum, to train my own engineers, and then I spun that off as Coding Dojo, people struggled. So I remember having special sessions and say, okay, anyone who's not getting OOP, and usually it was almost everyone except those who knew OOP before, I would walk them to a room and say, okay, let me try this, let me try this, let me try this analogy. Okay, and I tried everything, and and then I was able to get a lot of the people to understand it, but it took immense amount of time. But I kept trying. And then one day, I think it was early in the morning, I woke up and I said, you know what? I should try this analogy. I think this analogy may work. It was an Age of Empire analogy, a game that I used to play when I was a kid. So you know what? Why don't I use that as an example of OOP to teach about inheritance, teach about private methods, public methods, attributes, functions, constructor, inheritance, right? All of these concepts. And I did it. So I got my group of students who were struggling and said, you know what? I had this new thought. Can I teach you guys this new analogy and see if it helps? And then I did it. And then everyone at the end, I could see their eyes just glowing like, I get it now, Michael. I get it. I understand. And I was so happy because everyone in that room got it. So then what did I do? I went to my office and I created a video doing exactly what I did in the previous class or in that special session. It's a 7-minute video, and in 7 minutes, I teach OOP, and students just get it now. What used to take people weeks in Coding Dojo, now they get it in 7 minutes, conceptually. And then, now I have them go straight to assignments. It took me a long time to get to that point, right? So relentless focus on simplicity. You also got to have genuine care for the students. If you don't, I don't think any inspirations or breakthrough happens. I think a lot of breakthroughs happen if you really care about the students and you spend time and you really want to help them, then you will be blessed with inspirations on how to teach more effectively as a teacher. That's another side of me, but we won't go too much of that. Okay, so OOP is another example. Join statements, another one of those where I've really struggled. Students really had a hard time conceptualizing how to do join statements. They didn't know like what's going on. It seemed magical. Anything that seems magical are things that teacher just didn't explain in simplicity. That's it. It's not that it's really advanced. Magical just means I don't understand it, right? And that's what you need to tackle. But anyway, join statements. So I struggle. I did this. No one gets it. No one gets it. And then one day, I'm like, okay, this is not working. Okay, I'm going to print out these records indicating their database roles. I'm just going to give it to the students and say, I'm not even going to teach them anything. Okay, so these are the city records, a bunch of city names. These are the business records. These are the state records. Now, tell me how many businesses are in the state of California. And they have to kind of do it. And they say, how did you know there were 5 businesses in California? 3 businesses in Washington based on these database records. And they say, Michael, the reason I did it is, and they physically join these paper this way. And I said, that's right. That's exactly what you just did. What you showed me right now is how join statement works. And when you tell SQL, this is how you write the syntax so that SQL understands how you physically join these 2 records together and you overlap. And then they're like, I get it now. I finally get it. I've tried multiple sessions with these students for multiple courses, and a lot of them finally got it, but it took them days, weeks to really fully understand. And all of a sudden, they're getting it in minutes. So I made that into one of the standard exercise. I should have created that as part of the curriculum so that they can actually see that too. But anyway, there are these breakthrough moments. Algorithm map, same thing. I've tried really for years. How do I get people to think like a computer? So initially I had people do a lot of algorithms, write an algorithm for X, Y, and Z. And it didn't work. It worked for some people, but for people who are at level 0, they just struggle. One day, this is after I've been focused on teaching, computer science for 5 years. I'm like, do you know what? Instead of me having students create an algorithm, why don't I just write code and have them predict what the output is going to be? Let's first get them to understand how the computer processes information. Don't worry about writing algorithm. Here's a code. What do you think the computer is going to output? What about this? What about this? What about this? So I write a bunch of codes on the whiteboard and say, run this. Not on the computer, line by line. Tell me, here's a T diagram, line by line, tell me. That was a breakthrough. Huge breakthrough. What I was able to get students to be, usually with 3 to 4 weeks of intense learning, now I found students getting that point in hours. Hours! Not even days, hours. And I'm like, oh my goodness, this is a huge breakthrough. So I made an app to replicate what I did on that whiteboard. It's called the algorithm app. Now we have, everyone go through that. And again, what people learned in a few weeks, they got it down to hours now. Amazing. Each of that breakthrough accelerates people's learning tremendously. Not by 30%, 50%, by orders of magnitude. Okay, Rails course, Django course, same thing. By restructuring things, really thinking, how do I teach things, very simply, you will get inspirations and you will find that something just clicks and you will find a better way. This is how I was able to turn a course that was having a curriculum NPS of 6.5 on a scale of 0 to 10. And by just shifting things, the order, grouping things, trying to really teach things very simply, how I was able to get students to learn things 30 to 50% faster, sometimes a lot faster than that. And how students' perception of the course went from curriculum NPS of 6 and 6.5 to 8.5 or higher, right? Keeping things simple is not easy. It's not simple to keep things simple. You probably know that as teachers, as instructors. But really do the best that you can. Let me give you another analogy. So again, I told you I'm going to be very blunt. At Coding Dojo, I had a group of people that I was training to be, curriculum designers. There are 2 people that I worked with in particular that I absolutely loved working with, Spiros and Amy. Great people. I had them create a course on responsive web design. At that point, we didn't cover responsive web design comprehensive, and I thought it would be good for students to learn that. So I said, hey, look, you guys are some of my best instructors. I would like you to create a course on responsive web design. So they did. They worked really, really hard. Hardworking, great people. They spent about 2 weeks, maybe 3 weeks. They were busy with other tasks, but they prioritized this and they came up with the course. And the course was very comprehensive. Other people would have said, good job. I looked at it and I said, okay, well, let's look at the assignment. I'm thinking about the assignment landscape. I'm thinking about the UX graph that you're going to learn a little bit later. I'm thinking this looks not simple. It had like 20 tabs, bunch of assignments, and it seemed like there are about 10, minimum 10, but more likely like 30 hours of content, text and video content. And I'm like, I felt like this is just not simple enough. I mean, is it really that complex? And I remember Spiros, him and I worked together for long time. He looked at me and said, and he probably sensed my hesitation. I'm like, why is this so complex? And I remember Spiros telling me, Michael. So, or I think it was me who approached Spiros and said, Spiros, okay, this, if you just sit down with me and you explain to me about responsive web design, just assume I don't know anything about responsive web design, how long would it take you to teach me these? And Spiros like beamed up and said, Michael, I can teach you these in 20 minutes. I think for you, 20 minutes, I can teach you this, right? I'm like, okay, listen, Spiros, if you can teach me this in 20 minutes, why not teach this in 20 minutes? Why is it you're teaching this, and then you're teaching all these concepts, and in each of the tab there are videos, and then there are assignments. If you can really teach that in 20 minutes, that's 1 or 2 videos, right? And then he's like, oh. So Spiros and Amy went back to work. They deleted, I think they wiped out their entire course that they created. And then they came up with, I think, 3 tabs instead. 2 or 3 videos. And that was it. They really boiled it down to simplicity in essence. And they got it done. I was so proud of them for being done that. Most courses are the former course that Spiros and Amy created. Very comprehensive, covers everything. The latter course was the effective one. And where the students, after doing it, they're like, oh, this seems so simple. I get it. They don't know that it took Spiros and Amy hours and hours and hours to really get it down to that simplicity where it could be digested like as a pill, just very easily. You take it and then it's part of you now. Anyway, focus on simplicity. Try to find simple ways to teach. Try to discover winning analogies that help people understand. Do not create a comprehensive course. That's what the official documentations are for. Do not create a comprehensive course. Comprehensive courses are bad, 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 bad. Keep things simple, guys.